Okay, so in homework 4 we've got the sets EF, so 2 elements in A, and B, which has 6 elements, are given. We're asked how many possible sets K can be written satisfying these conditions. So we have that A is a subset of K, which means that K must also contain A, which is EF. But we've also got that K is a subset of B, which means that we could also have elements from B. And we can see if we discount E and F, discount E and F, then we can see that we've got an additional 4 elements that we could possibly use. So how many subsets is that? Well, if there's 4 possible elements, then we know that 2 to the power of n, if we have the n as the number of elements, 2 to the power of 4 here would be 16 possible subsets. Now what if we have this condition here where K is not equal to A, so that means that we are not including the set EF? Well, that means we had 16, but now we have 1 less. Nothing too difficult there. Alright, question 2. We've got a different set K, and find the number of subsets of K which do not include 4. So if we take away 4 here from our set here K, we originally had 1, 2, 3, 4, 5, 6 elements, and so not including 4, we have 5 elements remaining, so 2 to the power of 5. So our answer will be 32. How many would include 4? So that would mean we're starting with 4. How many elements we have? Well, we have 5 elements left, so that gives us, again, 32. 2 to the power of 5. We can also look at part A here and see that the total number would be 2 to the power of 6, which is 64. And if we deducted our answer from part A, we would also get 32. Alright, so what happens if we include 0 and 2? So that means both of them must be in the set. Well, then we could have, let's erase this here, if we have 0 and 2 already in the set, well, that gives us 4 possible elements. And so that gives us 2 to the power of 4, which is 16. So in part D, we can see the only difference here, we've got the same bit here, we've got include 0 and 2, but the only difference here is that does not. So that means basically we're going to have to take the total. Remember, the total here was 64. So we could say 64 minus the ones that do include it from the question beforehand, and so that gives us 48. Let's go ahead to E now, and we see that the only difference here is that instead of and, we have or. So if we recognise that and is the intersection and or is the union, if we draw up a quick Venn diagram here where this is the universal set, we've got the set with 0 and 2, and remember was the intersection, so this answer here, 16, was the intersection where they both happen, they both occur. We can look here at actually part B where it says the ones that include 4 and use the same logic to realise that the same ones that include 0 would have to also be 16, and also the number that would include 2 would have to be 32, which means that 16 plus 16, this group here of 2, would have to add up to 32. Also, we knew that the universal set, the number was 64, so that leaves 16 here in this outer bit, and that is the bit that does not include 0 or 2. So if we shade that region to make it a bit more obvious, we can see that this is the section here shaded that is not including 0 or 2. There is an easier way to do this. Can you spot it? Hopefully you could. If we do not include 0 or 2 here, then we can see that we have 4 elements remaining. So if we take 2 to the power of 4, the number of elements remaining is 16 as well. So we can see that here on the Venn diagram, or we can work it out with the number of subset formula. So now we have another situation here where we've got some similarities. Include 0 or 2. So these questions are related. Now, the ones that do not include 0 or 2, well, we could look at it from the Venn diagram and see, okay, 0 or 2 would be 3 times 16, which would be 48. But there is another way of doing it. Can you spot it? That's right, the key word here was not, and so here we do not see not, and so we can use the complement. So the total minus the answer in part E. So we had 64 minus 16, and we would also get the same answer, 48. So for the last part, part G, include 6 and 10. Well, let's write this out, shall we? Include 6 and 10, but not 8. So if we go back up here to our set K, if we've already got 6 and 10 being used, but also we're told not 8, so we can also cross out 8. What do we have left? We have 3 possible elements. You guessed it, to the power of 3, and so there are 8 subsets of K.